Thank you. Great. And this is actually definitely not my first time in Singapore. I come here quite often. As Dave hinted, I will actually be moving here in a couple of months. But it's the first time I'm speaking at an event here. So I'm super happy and very grateful to the organizers. And thank you for coming. What I want to do is talk a little bit about the enterprise integration patterns, right? This is a book we wrote 14 years ago now. It seems like a very long time ago. So talk just a little bit about what's in there, but then talk about where we're taking this topic, right? What is next, and reflect a little bit what's behind patterns and pattern languages. So I'm not going to talk so much about messaging, but more about the thought process behind it, right? What goes on in the head of a pattern author, and how do these books and these pattern languages actually come about? Because I think that's the part that's much better done in a live conversation, right? The patterns themselves are easy to read up in the book or on the website. So let's start with messaging, right? In the end, what is enterprise integration messaging all about? You're trying to get two systems to communicate with each other, right? In order to do so, you need some fundamental mechanisms, right? You need to somehow package the data or what they're supposed to say to each other, and then you need to transport it to the other end. And in the end, messaging is nothing else but the most simple possible form in which you can do that, right? You're taking the data, you package it in a message, you stick the message on the channel because somehow it must get from left to right, and then the left side publishes the message and the right side consumes the message. And this simplicity has some very distinct advantages, right? So on one hand, it's a simple interaction model. If you took anything away, you basically have no more communication at all, right? So this is the simplest thing you can possibly do. There's no objects, classes, instances, inheritance, delegations, right? All these call stacks, return statements, all that stuff does not exist here. It's like piece of data goes from left to right. The other thing is by making the channel explicit, right? We don't say it magically goes from A to B. There's a channel that does that. We have some location independence. You know, the left side doesn't talk to the right side, but the left side talks to a channel, and the right side receives from a channel. So you have some decoupling there, and that's a nice property. And last but not least, the channel can also buffer these messages, can store these messages, so they have a temporal decoupling, right? So if the right-hand side is temporarily unavailable or a little bit bogged down or slow, the left-hand side can still fire off messages without being bogged down by the right-hand side. So in the end, the simplicity has some distinct advantages, and what I often highlight is that this is an interaction style that is honest to the constraints of the underlying medium. Right? Things might be delayed, things might work at different speed, etc. So messaging acknowledges that, right? Other models like remote procedure calls, you know, they try to make remote communication look like local communication. And in the end, it's a good idea to have these kind of abstractions, right? If you can do this, it's valuable because it forces you, or it keeps you from having to deal with all the little nasty things of remote communication. The problem is remote procedure call is not an abstraction, it's actually an illusion, right? And abstractions are a good thing, but illusions are not a good thing because an illusion portrays something that it actually isn't. And while that's entertaining maybe at the magic show, it's not at all entertaining when you're actually programming against an illusion and you ultimately find out that it's not reflecting the real truth. So messaging tries to avoid that by giving you an architectural style that really matches the capabilities and limitations of the underlying transport. Now, this has some distinct advantages, so a little pitch for why messaging is so interesting, right? We already said you have the temporal decoupling. That has the nice consequence also that it limits failure propagation. If one part of the system becomes unavailable or slow for a short amount of time, that failure doesn't propagate. Or likewise, if one part of the system is propagated and just spews out billions of messages, that also doesn't propagate, right? And we all probably have heard of concepts like circuit breakers, etc. So the thought of limiting failure propagation is actually a very important one to increase the stability of a system, right? If something goes wrong, you want to contain that. You don't want this to go through the whole system. The other advantage of this temporal decoupling is throttling. Basically, the receiving end can process incoming data at the rate that is optimal for it. And if more data comes in, if more requests come in, they get queued up, right? So that makes it much easier to tune the system because it works at its own desired optimal rate. The example to this I always give is very simple. It's like in a supermarket, right? Nobody likes to be in the queue, right, because you have to wait. But at the end of the day, it's a much more efficient model that when there's one cashier and one cashier is overloaded, they will process nicely one customer at a time, and you work off the queue. So the cashier can work as efficiently as they can possibly work. If you didn't have a queue and everybody just goes to the cashier at the same time and slams the groceries on the desk at the same time, right, this whole thing would grind to a halt very quickly, right? And those are the advantages of throttling. You let the components work at the maximum rate at which they can work and no higher. The location decoupling allows you to inject intermediates, right? A doesn't actually know whether it's talking to B. It could be talking to an intermediate that's doing some translation or some other necessary activities, and that in the end we'll see is the basis for many of the patterns. And last but not least, a nice property of these systems is they're optimized for throughput. They're optimized for how many units, how many messages can I get through this system per a certain amount of time. And if you think about many businesses are throughput based, right? It's just like a long time ago I wrote a somewhat famous article about Starbucks does not use two-phase commit, right? And that is all based on the fact that Starbucks is more interested in throughput than in latency. How many customers do they get through per hour? How many drinks do they sell per hour? Because that throughput is the source of revenue. So these throughput optimized systems often have a good match to the real life, right? Our real life incentive matches the way the architecture is done. And again, this makes it natural or honest in a way to me that the architecture we design matches the real world needs, but also the real world constraints. So this is a little bit of sort of a pet peeve of mine, right? Largely the systems we build or we're building, they serve a purpose in the real world, right? Our software is designed to do something useful in the real world, right? It's automating an ordering system or fulfillment system or calculating something, right? So it's there to help us deal with the real world. The interesting thing about it is that when we start building these systems, we tend to make an abstraction that somehow portrays the real world as some sort of ideal form, right? We want everything to be transactional. We want everything to be two-phase commit. We want everything to be binary, right? So we're making a model that's a little bit idealistic, and then when we find that it doesn't really work that well with the real world, we tend to blame the real world, right? Say, oh, well, this is not the way we want to have it. And I think actually the opposite is true. The real world is actually what we're dealing with, and we should make our architectures match that. The real world is asynchronous, and it is failure prone. People send letters, people talk to each other, people have to go over to tell you something. So the real life, the real world actually knows very well how to deal with these kind of things. So to me, it's always odd that in many of our system architectures, we try to pretend that those kind of constraints don't exist, and at the end, we're surprised that we have problems with these systems. And that's really the essence behind the Starbucks story. It's like, look at Starbucks. They don't use two-phase commit either, right? You might have paid already, and the coffee maker breaks. This can happen. It's not a two-phase commit. They will just give you your money back. It's totally natural. So to the extent you can make your systems learn from the way the real world functions, I think it's actually a very positive thing. And the real world, as I said, it is asynchronous, and it is unreliable. So it's very much like a message-based architecture. So there's one catch, though, with the message-based architectures, and that is the runtime behavior is very different than a normal program, right? A normal program is based on a call stack, and a call stack is very convenient. One method calls another method, the other method does its thing, and when it's done with its thing, then it returns to the calling method. So that has the distinct advantage that the design time structure and the runtime structure are very similar, right? You see one method is another method, you see the name of the called method, right? It's very easy to put together when you see the code what happens at runtime. And that's an advantage because it helps with debugging, it keeps us from making mistakes. It's convenient. On the other hand, it's also constraining because the demands on a runtime architecture are very different than on a design time architecture. Like the design time you want to be easy to understand and easy to change and easy to maintain. The runtime structure you want to be fast, scalable, dynamic, right? They're different things. So in the end, making these more separate actually has distinct advantages, but it has one disadvantage. It makes it more difficult for us to transfer our thinking from one to the other. Because your design time structure, your code structure, and the way the system behaves at runtime are actually becoming more different, right? The messaging systems are more like on the right-hand side, it's more like a free flow of data through the system, and I couldn't even draw this properly. Things don't necessarily happen in the same order. You know, messages pass each other, etc. So there's really much more complexity going on. So while we like the fact that the runtime has sort of a life of its own and has more flexibility, we struggle with the fact that it's harder to design such systems. So there comes the idea of making the design of such systems easier to understand and more approachable by having design patterns. And we'll talk a lot about what these patterns do and how they come about. So in order to get that started, we should think about what is really needed to design a messaging system, right? What do we need? It starts very simple, right? 2 endpoints, a message, and a channel. So these are certainly ingredients. So when you build a messaging system, you need to have a transport, right? You need some sort of channel. You need to think about what a message looks like, right? Do you stuff everything into one message? Do you make smaller messages? Do you have different structures? What do these messages mean, right? You need to think a little bit about what you put in this message, right? Then sometimes the message has to go different places, right? It needs to be routed, so that's another aspect. Often when you connect systems with messaging, you don't have full control over the systems and the data formats they need, so you might have to do some translation in between. You know, that's another major concern. And then next, you need to think about your endpoints, right? These applications, they're often synchronous and object-oriented, but the messaging world is asynchronous and document or message-oriented, so you need some interface layer. We need something that brings those two worlds together. And then last but not least, because you're dealing with a quite dynamic system, you need to have runtime monitoring. You need to understand what the system does at runtime. So that's what you do when you design a messaging system. Yeah, pretty certainly you need to deal with all these aspects. So what we've done with the messaging patterns is basically make patterns for each of those categories. And that's the structure of the book. These are essentially the chapters, the core chapters of the book. It's like, here's the things you need to do when you design a messaging solution, and we want to help you do that, avoid mistakes, make this more easy by documenting messaging patterns. And that's exactly what we did 14 years ago. So 2003, this book came out, fairly well-known enterprise integration patterns translated into all sorts of messages, and actually became a fairly sizable book. And that was surprising to us even. We didn't think we were going to write a 700-page book about messaging, because messaging is a relatively simple style, but as I said, the simplicity brings a lot of design considerations with it. So as we started to tackle all the trade-offs on concerns and considerations, the book started growing and growing. In the end, we were quite surprised that it ended up being a 700-page book. Things that made us happy about the book is that we've taken the concept of the patterns in many different formats. So we made playing cards. We actually have playing cards where you have the patterns and the explanations. You can actually lay them out in your design with actual playing cards. We made all the icons and the names of the patterns available as Creative Commons. So people put them into tooling, into IDEs, into different documents, right? It's free for people to use. And that made us very happy. And most of the open source ESBs, whether it's the Mule, the Camels, the Spring integration, any of them, they all use the pattern language. And that's the main reason that 14 years later, people still find this very relevant. So recently I've looked at sort of modern messaging systems and to see how much of these patterns are still in there. So here's a picture actually from Google Cloud pops up, right? My old buddies at Google, they sent me a similar picture of their system structure. And I started to look as, hey, are there actually some of our design patterns still represented in there? And the answer is, yeah, it was quite easy. There's a competing consumer pattern. It means one message gets on the channel, but only one consumer out of multiple actually consumes the message. So they're competing in a sense. And then there's the opposite. There's a publish-subscribe channel, right? One message goes on a channel, and every subscriber gets a copy of it. And in the end, it actually helped them explain what they had done much better, because many messaging systems use either point-to-point or publish-subscribe. So competing consumers or publish-subscribe, but they have a combination. Kafka is similar, right? They combine the two, and in the end, it can be quite confusing. So if you have one subscription to a topic and two subscribers, you're building competing consumers. You can see message 2 only goes to B1 and not to B2. versus if you have one topic and two subscriptions, you're building publish subscribe. So message 3 goes to both. So it becomes very easy to explain the behavior, and if anybody is interested in more detail about competing consumers or publish subscribe channels, they can look at the website and read up on it. You don't need to explain everything. There's a reference. And there's many other patterns. There's durable subscribers, transactional clients, polling consumers, etc. So the answer was yes, modern messaging systems. And you can do the same with Amazon SQS. It has dead message queue, channel purger. It has many other patterns built in as well. So that was good news, right? The patterns basically pass the test of time, and modern systems still have the same kind of patterns in them. The second test I did is, well, what does it take to implement the patterns on one of those modern runtime platforms? And here I took the Google Cloud Functions, right? It's sort of, they're like Amazon Lambda. It's one of the serverless implementations, right? In this case, the Google flavor. And I built a simple content-based router. What does this content-based router do? It receives a message, it looks at the message type, and depending on the message type, it sends it on a widget versus gadget channel. Basically, it's a router that routes the message left or right, depending on the content. The good news, it turns out, this is very easily implemented in Cloud Functions, right? You have the decision on the bottom, whether a message goes left and right, and you have the code on the top that basically parses the message, does the base 64 decoding, does the JSON parsing, then it makes the decision, right? And then it publishes. You can see topic.publish in the middle about there. So that means it retrieves the topic, and then based on the topic, it publishes the message. So I guess it wasn't a huge surprise that this is implementable, but what's very nice to me is that is all the code that is needed. When we wrote the examples for the book, we found actually that the examples were like this big, and the relevant code was like this small. What we actually wanted to print in the book was like 7 lines, but the real code was like 50 lines because of all the harnessing skeleton around it. And that's where I think we should appreciate really some of the progress we have in the frameworks and platforms, because all that glue logic, all that stuff goes away, right? So basically the command line at the bottom wires this together. It tells where to listen to, right? I have this bucket that I'm listening to, and the topic, right, the trigger topic at the bottom you see. So it's just the topic orders triggers this, and there's almost no glue logic. There's like 2 or 3 lines where I would say, okay, if we could reduce that, I would be even happier, right? Sort of the base 64, the JSON parsing, right? You can put that in a base class or somewhere and make this disappear also. But in the end, there's almost no noise left, right? And that is a very nice thing. So I think on that end, we made a lot of progress and should be very happy about that. So that's about, so this was messaging, right? So messaging patterns, how did this come about? And it stood the test of time. Let's talk about conversations a little bit. So one of the few criticisms our book got was that it's called enterprise integration patterns, but really it just talks about messaging. And people say, oh, there's this topic like data mapping and data architectures. You guys didn't cover this. Right? And I said, well, there's, the snip answer to that is you should have read the subtitle of the book, which is Implementing Designing Messaging Solution. Is basically you need to read the fine print. Right? I work for an insurance company, so we know very well people need to read the fine print, and with books it's the same way. But the less tongue-in-cheek answer is, well, maybe this is just the first volume of a series of books. Right? And it was 700 pages, so we certainly didn't want to pack more stuff into the book, right? But saying, why wouldn't there be a volume 2? Right? And the best candidate for a volume 2 is what I call conversations. So messaging is a very elegant architectural style. It's this pipes and filters. It shows how a message flows to largely stateless components, right? So it's very scalable. We have all this decoupling we talked about. So it has really, really nice properties. The catch is a little bit, that doesn't cover all real life scenarios, especially in a business-to-business scenario. You send something, you want the confirmation back. Some things are just very request-response. Some things are a back and forth and back and forth. You're going to get a quote. People give you a price. You negotiate. Ultimately, you make an agreement. You place an order. You get an order confirmation, right? Like a lot of communications just have a lot of back and forth. and they don't look so much like the picture on the left, they look a little bit more like the picture on the right. So in the end, you realize that when you design these kind of systems, there's different viewpoints, right? There's a single system, but there's different viewpoints on it. Once you focus on the message and the flow of the message, and once you focus on the participants and what happens over time. And they're just two different viewpoints. And such is architecture, right? Architecture is about having a model of reality, right? It's not reality, it's a model. And based on the model, you can reason about your system, right? That's the essence of doing software architecture. You abstract, you find a model, and based on this model, you can make decisions, you can find problems, you can choose between alternatives, you can communicate with each other, right? That's the purpose of software architecture. So here are two different lenses, right? Two different models on a system. One's very much looking at the message, and one's very much looking at what happens over time. And you will realize that, maybe I should go forward, okay. And you realize that suddenly you have a whole different vocabulary and a whole different way of looking at a system. So here's an example, you guys know I like coffee shops, so it's again a coffee shop example, very, very simple. What happens, right? Somebody places an order, you need to make the drinks, you need to make the coffee beverage, you need to also tell them how much it costs, like some sort of invoice, and they need to make a payment, and then you deliver the drinks. So there's a simple conversation, right? You place an order, you get an invoice, you submit a payment, and you receive the drinks. Now, questions come. Can I pay before the invoice comes? Because I go to Starbucks every day. I know how overpriced it is. So I know my chai latte costs like whatever, 7 Singapore dollars and 35 cents. So I can just give them the money before they even told me how much it is. Is that allowed? Is that not allowed? Right? So other way around, do I have to pay before I get the drinks? Right? Is there a sequence pre-programmed, right? That they don't give me my drinks until I have paid. I don't know, I haven't tested at Starbucks, right? You can just stand there and not pay and see whether they still deliver your drinks. They may or may not, right? So these are the rules of the conversation. And both parties need to agree, right? Because otherwise you get silly deadlock states, right? Because if you're not paying because you're waiting for your drink and they say, well, I'm not giving you a drink until you're paid, you are in a classic deadlock situation. You can wait for that forever, right? So that's not supposed to happen. So suddenly you have a whole different kind of conversation or a whole different kind of thought process, let's say, right? And you realize that having some patterns, having some help here could be quite handy, right? Because designing these kind of protocols is not particularly trivial. The other thing that you realize is suddenly there's a lot of talk about state. I should actually do a search in our original book and find how many times we use the word state. Shouldn't be that often, actually, because the messaging systems, the state is in the message and everything else is largely stateless. Here it's all about state. Where are you, right? And there's a conversation state. Where is this interaction? But then each participant has their own projection of this state, right? They have their own different view. Like in this case, on the left-hand side, they're counting their money, they're trying to make their payment, versus the right side is waiting for the payment and is making drinks. So they are at the similar spot in this conversation. That's a good thing because they're not getting deadlocked, but they're doing different things, right? So there's different views on this state of this conversation. One of the advantages of talking more about state is that it lets you deal with a new class of problems. Another comment on our book was, you're lacking things like error handling, right? Enterprise integration patterns rarely ever talks about error handling. It has an invalid message channel and it has a dead letter queue, but that's about it. The reason for that is relatively simple. Error handling most of the time requires you to have some notion of state. I mean, how do you do error handling, right? You figure out how far you got, and you figure out that something went wrong, and you figure out what you didn't get to, and out of the delta, you go fix something. Either you retry the part that you didn't get to, or you undo the part that you already did, or somehow you try to get yourself into a consistent state, right? What is error handling, right? Something went wrong, you need to go back into a consistent state, but you can only do this if you have a notion of state. Enterprise integration patterns, messaging patterns doesn't have a strong notion of state, which is a huge advantage because that's how you get this decoupled, scalable architecture, but it makes it very difficult to talk about error handling. So that's where the conversation patterns come in very, very handy, because suddenly you have the vocabulary to talk about state. So a good example that really drives home the point between the messaging and the conversation patterns is to use two patterns that sound very similar. The one is called publish subscribe, and the second one is called subscribe notify. Now first, I always have a small pet peeve between publish subscribe, like pub sub, because when you think about it, it should be called sub pub, because the subscription actually comes before the publications, right? It's called pub sub, but it's like, no, you should be subscribing to something, and then when somebody publishes something, you get the message. So I think it's in the wrong order, and it's actually worse. If you think about it, publishing and subscribing are totally not symmetric, right? The corresponding action to publishing is receiving, right? Somebody publishes a message, you receive the message. Subscribing is a meta operation. Now, subscribing is something you do once, and then whenever somebody publishes something, you get the message. So publishing and subscribing are not equivalent in any way at all. You know, subscribing is something you do once. It's a composition of the system. You say component B wants to receive messages on component A, so you subscribe, so you compose the system. And then publishing is a runtime act. It's like, a million messages. Here's a million messages. So PubSub, if you really think about it, is a very poor name. It's cute. It sounds good, right? PubSub, it sounds nice. But from a point of view of what you really want to express, it's a horrible name. And we'll come to this. Patterns are very much, you might think I'm splitting hairs now, but when you start making patterns and pattern names, it's exactly those things, those little things that make a good pattern language or not. So the interesting thing is what I just talked about, that you receive messages over time. The left picture doesn't express at all. The left picture pretends there's one message and is very much concerned with where does this message go. Well, the answer we know, it goes to all the subscribers. The right-hand side is much more concerned about what happens over time. I don't subscribe to just receive one message. I subscribe to receive messages over time. Now, here it becomes very clear again. The real system does both, right? Each message that is published goes to all the subscribers, but I publish messages over time. So the real system behavior is both. We just use two different lenses because it makes it easier to think about it. If I had to draw two pictures at once, it would be a giant mess. So it's easier for us to separate the two kind of concerns. Another comment is the right-hand side leads to very different questions. The natural question on the right-hand side is, well, how long does this go for? Like infinite is always a dangerous word in computer science, right? Nothing is ever infinite. So if we say, oh, this goes indefinitely, you start wondering, right? Does this go forever? Probably not. What happens if the provider dies and restarts? Is my subscription still there? What if the subscriber goes away and comes away? Is the subscription still there, right? Whole different kind of questions come, and you start talking about things like leases, like the duration of a subscription. Like a magazine, you subscribe for 1 year. If you don't pay again, if you don't renew, you will no longer get the magazines. DHCP, you lease IP addresses, you need to renew, right? It doesn't last indefinitely. So on the right-hand side, you suddenly have whole different design questions. And the nice thing is, you can find all the matching patterns to help people address those design questions that on the left side never came up. So that's why even so we're still dealing with messaging systems, the conversation patterns are a whole new world. It's a whole new set of patterns. Now what we find is that designing these kind of conversations is not easy. Really it's protocol design, right? And you have all this kind of stuff, completeness. Like does this conversation actually reach the end in all circumstances? Deadlocks, like does this, as I said, the one waits for the drink, the other one waits for the payment, right? You will never agree, you will never move. Error states, right? You can have a complex set of error states that can happen. How do you recover from them? Your state space might explode into an enormous complexity, right, that nobody can understand, etc., etc. It's also not as easy to draw these kind of protocols, right? Because multiple things happen at the same time over time. To get this on a piece of paper is much harder, actually, right? And there's been many attempts made, right? Basically, like UML 2. Like UML 1, the sequence diagrams had really, really poor semantic, right? Like UML 1 sequence diagrams basically showed one example of a possible conversation, right? The messages could flow like this, but it couldn't express any rules, right? And here it's all about the rules. UML2 added notation, but it's horrible. It has like the little triangle in a box with something. I mean, to be honest, I don't even really remember because nobody uses that very much. Who uses UML2 sequence diagrams? I'll talk to you at the party and ask you. Oh, okay, I will ask you to explain a little bit. You can remind me what the syntax is like because I find it not very intuitive, right? It's a little weird. It's better from the semantics, but it's weird visually. Then BPMN is good, right? But it describes the conversation from the viewpoint of the endpoint processes. And we learned like 3 slides ago, it is 2 different things, right? The conversation has its own design and the endpoints are just a projection. So BPMN, I think, is from the notation much more intuitive from the point of view, but it describes the conversation indirectly, right? Because it describes it by what's going on in the endpoints. So quite a few challenges in the conversations. So now we know what conversations are, and we know we want to make conversation patterns. So let's look at pattern languages, right? So how do these patterns actually come about, and how does one make pattern languages? Well, where the patterns come from, we do know, and that it comes from architecture, right? There's Christopher Alexander, he's an architect, like building architect, right? And he wrote this book, A Pattern Language. So who's actually read the book? Pattern Language? All pages? Yeah, all 1,200, whatever, it's like 1,100 pages. It's like, yeah, exactly, me neither. So my hand goes down as well. So it's a quite sizable book. It has 253 patterns. Comparison, how many patterns in a gang of 4? That one you should know. 33, it's a little high. Anyone else? 23, close. Right? 23 patterns in gang of 4. So this is 253. So it's like 10 times more patterns. It's quite a tome. It's quite a body of work. Couple of things I like to remind people of. So don't have to read the 1,000 pages, but there's a few things to go back to look at the origin. So the patterns have a distinct name. Naming is quite important, right? So the bed alcove, and they have a sketch. And I think what's noteworthy is in the original design patterns book, the sketch is not an engineering drawing. Like in our design patterns, the gang of 4, it's a UML diagram. So that's our version of an engineering drawing, if you wish. Here it's intentionally not, it's a sketch, right? There's no measures, there's no materials, there's no thickness of the wall. The sketch is there to be evocative. The sketch is there to quickly convey the essence of this pattern. What is the essence of a pattern? You don't put your bed in the middle of the room because then all you do is run around the bed. You put the bed in a little nook, into an alcove, right? A, you feel cozy, right? And B, you don't have the problem of having this U-shaped room left, right? Where you basically have to just walk around the bed. Anybody who stays at hotels a lot knows this problem, right? You have a rectangular room, a big bed in the middle, and you have this kind of narrow U-shaped space around it that is actually not very useful. So that's what this pattern expresses very well. It has the forces. It doesn't just give you a solution. It has a design discussion. Why is this? Well, the negative space is awkward. That's the problem. So it discusses. It teaches, right? And I think that's the big difference between a pattern and a cookbook. A cookbook is like, well, follow the following steps, right? Chop the carrots, put them in the boiling water, put the potatoes, mash the whole thing, and whatever you get, right? It's just cookbook is follow these 12 steps. Don't ask too many questions, right? Design patterns are very different. It explains to you how did we come to the solution, right? Why are we doing this, right? So there's a big difference. And I think this is good to come back into. So there's a nice book like John Felicitas wrote a follow-up to the Gang of 4. He's was one of the Gang of 4 authors. So he wrote a nice follow-up that's called Pattern Hatching. It's partly a column he was writing for a magazine and partly sort of reflection on the book. And he says always when people say, oh, what is a design pattern? People always say it's a solution to a common problem within a context. And he says, well, that is only partly true because 3 very important things are missing. It needs to be recurring, right? It's only useful to write it down if this is a recurring problem, right? It needs to have these forces, the why as well as the how. It's not just like do this, right? If you want to turn left, use your left turn signal. That is not a pattern, right? It's just like, yeah, it's a solution, but it's just like do this. The pattern has a discussion. It explains why it's this way. And also John highlighted the importance of the name. The naming is actually quite critical. Another nice description of what design patterns are come from Ward Cunningham, and he basically said it's the chicken McNuggets of knowledge. If you're trying to teach people something, you package it into bites, into little bites, like the chicken McNuggets, right? The pattern is just big enough to be digestible and to be human digestible, because patterns are human-to-human communication mechanisms. They're not for code generation or making the system do something. The patterns are there for us to talk about designs and have a human conversation. And they're not invented, they're harvested. So when some people got our book about messaging, they said, oh, I already knew everything that's in this book. And I said, well, if you've worked with messaging systems for a couple of years, that is a good thing. Because the patterns are solutions to recurring problems. So if you work with messaging systems for a couple of years, it's very likely that you had these problems. So you know this kind of stuff. So for me, this was actually positive feedback. Right? I'll be surprised if you work with messaging for many years and you get my book on messaging patterns, and it's all new stuff to you. Something is wrong, either on your side or on our side with the book. So it's to be expected that you'll find things you've already done, but now it's cataloged, it's explained why it's this way, and it has a language around it, and it has naming. So coming back to the Gang of Four. So we concluded there's 23 patterns in this book. How are they structured? How is this book laid out? What are the chapters of the book? Or who has the book or who has read the book? Probably a lot of hands go up, right? Design Patterns, Gang of Four, yeah, don't be too shy, right? It's like they sold like 300,000 copies or something, right? Plus you can get PDFs everywhere. So there are people who certainly read this book. So it has a structure. It's not alphabetical, right? It has a structure. And actually, if you don't remember the structure very clearly, don't feel bad at all, because I didn't remember it as clearly as well. It has a structure, and this is the structure. It has a two-dimensional structure. The one is by scope. It has class patterns, and it has object patterns, because it's object-oriented, so it can distinguish class from instance. And then it has, basically it has creational, like factory, structural, and behavioral. So it has a structure, but the reason most of us don't remember is, so this table is actually in the book, right? The reason most of us don't remember this is because it's not very prominent in the book. They focused very much on the individual patterns, right? They're very much concerned with the idioms almost more, like the implementation of the patterns, how you make this in C++. So they were very much focused on implementation of the patterns. They were not so much focused on how do all these patterns fit together. Why is it 23? Could have been 24, 25, surely, right? In the end, they didn't write about this so much, and this happens, right? Because everybody's head is only so big, and at some point the book's just got to be done, right? Like scope control. So they focus on the patterns, not so much the structure. Right? And there's some other picture in the book, right? It talks about the relationships between the patterns, but it doesn't talk about it so much. So they put the patterns in the foreground, but they kind of skimmed a little bit on the pattern language aspect. And that is a bit of difference to the original book from Christopher Alexander. So notice the original book is not called Patterns. The original book is called Pattern Language. So it's very concerned with what language is formed out of. You have all these patterns with these names. They're very concerned with the sum. So this book is different. The patterns are much shorter. This book is much more concerned like how does it fit together. So this book has a very clear structure. And it's, it's very much described in the introduction. It says the patterns are ordered. There's a reason pattern A comes before pattern B. There's a clear order. And in this case, the order is macro to micro. It starts with like city zoning and how the way cities are structured. And it ends with where do you put your bed and where do you put your lamp. So it goes from like 50 square kilometers, like what does a whole city look like, to like, 50 square centimeters is like, where's my lamp, my light switch, where's my bed? And that was very intentional. So they spend a lot of time thinking about the structure of the pattern language. And in this case, they have mostly forward references. So if you use one pattern, it gives you hints at which pattern you should be using next. So for example, the bed alcove I showed, the simple example where they put the bed in the nook. One pattern that follows from that is varying ceiling height. You like to have a high living room, like here, it's nice to have a lot of space. In the bedroom, you don't need a 12-foot ceiling, really, right? You mostly sleep in there anyway. So why not make the bed alcove a little bit lower? It's actually cozier, right? So this is a pattern that follows. From bed alcove, once you use that, you should use varying ceiling heights. So very strong connection between the patterns. There's another book that talks very much about the connection between patterns and these pattern languages, really the combination, and that is the POSA 5, the Pattern-Oriented Software Architecture. So this is probably not a book that every software developer wants to read or should read. This is mostly written for people who really like pattern languages and design pattern languages. And I think the reason it's a separate volume is because Frank Buschmann, who's one of the authors on it, he had promised his wife that he would never write another book. You know, book writing, you know, it takes a lot of time, a lot of focus. It's a big strain on the relationship. So basically, he had to promise that this is the last book he's going to write. Of course, what happens when it's the last one? All good ideas have to go into this book, right? Last chance, right? So the book got bigger and bigger and bigger, and ultimately the publisher decided to split it into 2 books. So volume 4 is really about distributed system patterns, and then volume 5 is really just about patterns. So I'm happy they did, right? Because for me, it's a very useful book because it starts discussing how do patterns relate to each other. So patterns could stand in competition. You use pattern A or you use pattern B. Or patterns could collaborate, right? Like bed alcove and ceiling height. You know, they're very happy together. You can make pattern compounds and say, these patterns fit in one chapter, like Gang of 4 did, right? Like these creational patterns, like, okay, they fit in one chapter, but it doesn't talk about how they're related within this chapter, right? That's basically Gang of 4. Here's like 5 patterns. They have some commonalities. You know, be happy. Pattern sequences we saw. Design pattern, a pattern language, sorry. The book A Pattern Language, very much a pattern sequence. And you can have pattern collections. It's basically you have multiple compounds, and the different compounds have a relationship to each other. So bringing this back to our enterprise integration patterns, the original messaging patterns, here is our pattern language. Our pattern language is very much structured by the high-level architecture of a messaging system, right? You need an endpoint to get to interface between the application and the messaging. You need to design messages, channels, routers, translators, and systems management. So our pattern language is very much structured by, you know, the anatomy of a messaging system, and that is also reflected in the book. These are the chapters of the books, right? Router, translator, endpoints, etc. However, our pattern language also goes inside these boxes, so that's the high-level structure of the pattern language. We also have things like this, where we're saying there's many routing patterns, right, or in this sense, and there's different flavors of it. Like, does always one message go in or one message goes out? Yeah, in a message filter case, it may or it may not, right? And then you can start discussion. Is a message filter really a router, or is it more like a transformation, right? So these are in our chapter introductions. We have this decision tree, right? Do we want to use a split or an aggregator? You know, the opposites of each other, so they work well together, but they do opposite things, right? A filter is different than a content-based router, because when somebody uses a content-based router, they guarantee that for every message goes in, they get one out. Content-based routers don't eat messages. Filters eat messages, right? So you choose one or the other. So in the end, we have a macro structure of our pattern language, and then we have a microstructure of our pattern language, right? And this is the reflection we said. And then would say in the end, what makes a strong collection of patterns is really hinges on the pattern language, right? It's not just the individual elements, it's really how it comes together. That in the end makes a strong pattern language, because patterns are not meant to be used in isolation. They're used in combination with other patterns. So the strength of the language is a key contributor to how comfortable people are using this language. And in the end, it makes a bigger contribution to helping people design. Or taken another way, I said, the patterns are all known, right? We don't invent any patterns. We harvest them from actual experience. So writing down one pattern is handy, but we're not teaching people so much new stuff. We're teaching more people how to think about it. You know, we make sure they don't forget some aspects. We give it a nice icon, a nice name, but basically the pattern is known. So the real value comes from the combination, right? Help people navigate this pattern language, build solutions out of it. That is really value add. So let's put this all together, right? So we talked a little bit about where does messaging come from and some of the challenges, how we made the patterns. Then we looked at the pattern languages and how generically the pattern languages look like, and then how we applied it to the messaging patterns. So now it's time to apply the pattern language concept to the conversation patterns. And this is work in progress. I'm still thinking about this and playing with it. So I thought this temporal structure that I used in the messaging, right? What is all needed to make a system like this worked reasonably well. So I was thinking maybe you can do this with the conversation patterns again. So the first thing you need to do, you need to initiate a conversation. In order to do so, you need to have a conversation partner. You need to find somebody to talk to, and then usually there's some initiation. Authentication, protocol negotiation, data format negotiations, right? Handshakes. There's usually a little bit happens before you start the conversation. Just like humans, right? When they start talking, they first introduce themselves, right? They make a handshake, and then they start the real conversation. Technical systems are no different. And by the way, this is one of the reasons I call it conversation patterns and not protocol patterns, because as you probably noticed, I like drawing these analogies between real life and systems design. I feel they don't have to be so different, right? In this case, these conversations are very much like human conversations, right? If you walk into a dark room and you need to find somebody to talk to, you need to do discovery. It's like, hello, anybody out there? Somebody says, yes, I'm here. Like, okay, let's talk, right? It's no different with these kind of systems. So that's the first step. Once you have a conversation partner, you can talk with them directly, or you can talk through a middleman, right? Normally we like to talk directly, but sometimes we prefer to talk to a middleman. When we buy a house, we usually talk through a broker, right? Because we want to make sure there's no misunderstandings. So same in real life. And once you have this as a pattern language, then you can put things on top like resource management and ensuring consistency, error handling, two-phase commit, recovering from error states, right? That's the stuff on top. So the flow isn't quite as linear as I would like, but here's at least a reasonable structure of a pattern language. And you can see for each of those blocks, I have a set of patterns, right? And that's the structure of enterprise integration patterns 2, if you wish, right? This is the conversation pattern language. It has 6 major chapters. It's all out on the website, right? So you can follow along as I write this. So I would say it's time to dive into some of those patterns, right? To just give you a feeling. Discovery, right? You need somebody to talk to. We set the forces. Let's grab one of water. The forces are one of the important parts of the patterns, right? That's what distinguishes a pattern from a recipe. So what do you have to think about when you talk about discovery? You talk about shifting the responsibility between the provider and the consumer, right? Who has to do how much of getting this conversation set up? The other thing is, what's the arrival and departure rate, right? Is this like a scenario where the people who want a service come and go all the time, but the providers are somewhat static? Or is this the other way around, right? Where it's a static set of consumers, but the providers going all the time, right? Do you want intermediary or do you want direct, right? Do you want to have a centralized element that helps you make this discovery? Or do you say, no, I don't want to depend on a single point of failure? And even if you have a central element, the question remains, how does somebody discover the central element, right? So these are, or trust, right? Is actually everybody happy to talk to everybody? Maybe people don't want to be discovered, or people don't want to discover certain things, right? So there's a lot of considerations. And those are the forces, and what the patterns do, the patterns resolve those forces in a concrete scenario. They say, okay, given these forces, they're often conflicting, but knowing that, here's a set of common solution patterns I can define, and they resolve the forces in a certain trade-off. Right? And here's some examples, right? What do you do if you know nothing, right? You come proverbially into the dark room, right? And you have no idea. You probably yell out, anybody out there, right? You figure out, is there anybody I can talk to? Yes, and that's what's called sort of broadcast or dynamic discovery, right? You basically say, anybody out here? You don't even know how to address anybody because you don't know who's there. So the only thing you can do is broadcast. You can yell it out, anybody here. Classic example, DHCP, right? You're coming on the network, you don't have an IP address, you can't address anybody because they don't have your address. You have no idea who's on the network. You broadcast. You say, come on, somebody give me an IP address. In this case, there's special providers. You're like the DHCP provider. Who gives you an address? Who responds? Could be more than one, right? And there's algorithms to resolve this. Yeah, and this is a classic example of, if you absolutely know nothing, how to discover a conversation partner. The downside with this is, if new participants come and go a lot, you end up flooding your network. Basically, you will never be able to have a decent conversation because your dark room is going to be full of anybody out there, anybody out there, anybody out there, right? People come and go, and basically all the network does is discover and not actually having real conversations. So you can turn this around and say, rather than everybody coming in and yelling, you could let the people who are already there announce themselves. Every minute you can say, hey, I'm Gregor, I'm here. Right? Anybody wants to talk to me, my name is Gregor. Say, hey, Gregor, this and that, we can have a conversation. Right? And this is basically the opposite, right? This is advertise availability. So, hey, I'm Gregor, I'm happy for people to talk to me. And you do this also as a broadcast, but you will do this at certain intervals, so you can choose. So if you have a lot of people coming and going, this probably works a little bit better. And this is one of the reasons why this works with Wi-Fi hotspots, right? The providers don't change very much. Yeah, I mean, you walk around, you find new providers, but the consumers come and go all the time, right? I mean, just now 100 people walked in here, right, and want to have a Wi-Fi provider. If all 100 of you said, oh, anybody out there, right, it would be a huge congestion. It's much easier for one provider to broadcast and say, hey, here's Wi-Fi, right? If you want to talk with me, here's my address, here's my SSID. Of course, the next thing you can do is like, well, either way you have a broadcast, right? If you know nothing, you need to broadcast either the consumer or the provider. If you want to avoid that, the answer is you make a registry, right? You make it look up somewhere like a directory. You go on the yellow pages and it will tell you who is there. Of course, they can only tell you because they registered beforehand. So this has the advantage that you no longer have to broadcast. It has the disadvantage that things need to register and somebody needs to find the directory. So maybe you do dynamic discovery to find the directory, and from there on you talk to the directory. Also not bad, right? You go into the dark room and say, come on, do we have a directory? And somebody says, yep, we got. And then from there on, any other requests are no longer broadcast, right? They go point to point. And you guys, I mean, I'm sure you guys all know this, right? This is not about inventing new things. This is giving better vocabulary and talking about it. So sometimes, when you want to discover somebody, the party you want to talk to depends on who you're talking to already. It's not context-free, right? It's not like coming in the room, anybody out there, that's context-free, right? Anybody will be good. Sometimes you have context. Let's say you're talking to Amazon, and Amazon is shipping your package. You want to talk to the shipper who shipped that package. You don't want to discover any shipping company. You want to talk to DHL or whoever they used, right? So basically who you want to talk to depends on who you're already talking to. Could be also a matter of trust. I don't want to talk to strangers. I want to talk to friends of my friends. So I ask my friends for a referral, right? Classic pattern. This is a referral. Just like in real life, right? Do you know a good plumber, right? I ask my friends, right? I get a referral because I trust them more. Once you have this vocabulary, you can get into interesting discussions. Is basically a directory just a special case of a referral, right? You could say, right? It's a referral that doesn't have a lot of context and it's specialized to make these referrals for new connections, right? I would say, and this is stuff I'm still thinking about it. It's not a sort of catch question, right? It's like, and the more I think about it is, yeah, I think a directory is actually a special case of a referral, which gives references, but within a specific context. And those are nice discussions you can start having once you have the pattern language and once the language meshes. And you can start, similar to Gang of Four, you can start, structuring this, right? So you can divide this into, is there an intermediary or not? Like if there isn't, you have to do the broadcast. And then you can say, is it driven by consumer? This is like, hey, anybody out there, dynamic discovery, or by provider. It's like, hey, Wi-Fi, I'm here, I'm a hotspot, right? And then you have directories and you have referrals. And I'm still thinking about whether the consult directory and referral should be in the same box or different boxes. But that's a fun part of writing pattern languages, right? You get to deal with these little nuances, and you only find those nuances because you have made the language. And that's where the value comes from, right? You can tell people about these nuances, and in the end, help them make better designs because you made a better vocabulary that allows that. And then the patterns go on, right? So we have discovered a conversation partner, so we can have direct conversations. We can also use intermediaries, right? So there might be coordinators who coordinate a conversation. There might be a simple intermediary in the middle, or there might be folks that I call connectors, right? A registry or referral is a classic connector, right? I talk to a third party to make a connection, but once I have the connection, I'm allowed to talk directly. Well, that's a directory lookup, right, or a referral, right? Once I have the referral, I'm allowed to talk directly, so I call them connectors. And now I can talk about, right, should I have a chapter about connectors, and should referral and consult directory be in there, right? Those, this is sort of a look into my head as a pattern author, right? This is the stuff I'm still thinking about, and I'm still refining. And here are just some examples. We don't need to dive into a lot of detail. It's all on the website. Classic patterns like a proxy. Sometimes you don't want to talk to the other partner directly, right? Because you want to be hidden. So some people use that, right? They use internet proxy to not reveal the address. But a proxy could also be used by your company. Like my company has an outbound internet proxy because they don't want me to talk to just anybody, right? They want me to talk to only safe websites, right? So interesting idea, same construct, same solution, but different intents. So in the end, I'm probably going to split this pattern into two different patterns because even though the pattern has the same solution, we said the pattern isn't just the solution. The pattern is explaining why it's done this way. So if you have a different intent, it's probably two different patterns, even though the solution looks the same. And if you're really well-versed in Gang of Four, there are two patterns in there that have the same structure, and I think it's state and observer, if I remember correctly. Have a look. Gang of Four has two patterns that look exactly the same from the solution, but they're two different patterns because different intent. So I should probably split this pattern. There should be a proxy that protects my identity, and there should be a proxy that controls communication. Right? I need to find good names for those. Other things you might do, you might be able to only make outbound connections. So you're not allowed to receive inbound connections. So what you do if somebody wants to talk to you, they place the message somewhere, and you look whether you have a message. Queuing systems are like this. SQS, Blackboard architectures, very classic, right? I call this a relay. And so on and so forth, right? You might be talking to one party who in return talks to multiple parties and gives you a composite answer back. This has a very natural mapping to business model. These are all the find me cheap car insurance, find me housing. This is the broker marketplace, right? I want to find the best deal, but I only want to talk to one party, and the one party talks to 50 parties and finds me the best deal. Hopefully it's the best deal for me, not the best deal for them. Both models exist, right? Always be careful who the middleman works for, right? They don't always work for you. Coming to the end, right? Now we have these patterns and pattern languages, right? So we see how we structure this. Now, these patterns work together, right? So as we said, the strength, the power of the pattern language comes from being able to navigate this space. So I'm working on this as well. And in pipes and filters scenario, the way you compose is very easy. You just string them together. It's like sort of pearls on a chain, right? So here it's a little bit tougher because it's not so linear. So one thing you can do, yes, you can string them together. So one conversation happens after another conversation. Prime example is you discover first and then you have a request response, right? The two things, just one happens after the other. What can also happen is what I call expansion. So there's a higher level conversation going on and a more detailed conversation. So think briefly, like 3 slides back, we had this relay, right? That in order for somebody to send me a message, they put it in the relay and I pick it up. It's a whole conversation of itself. But at the higher level, it looks just like one message going from left to right. So basically, there's a higher order conversation going on and a lower conversation going. So for example, it might be a request response, but both the request and the response might be going through a relay, right? So it's kind of interesting. And this happens here when people use walkie-talkie, right? They will say something, they will say over or Roger. That's the low-level conversation, just basically to make sure not everybody talks at the same time. But of course, that's not the purpose of the conversation, right? The purpose of the conversation is they talk about something else, like where do they meet? Right? It's like two conversations layered, and there's some complexity, and the patterns should help you deal with that complexity. And then the last one is multiple conversations might happen at the same time and just overlay. Prime example is we had the subscribe notify, right? We said you subscribe once and then you receive all the notifications, and the question came, well, how long does this go for? A classic pattern to determine how long this goes for is the lease, right? They said you will get the notifications for 1 hour, and if I don't hear from you, it will stop. So you should renew, just like DHCP. Right? So now you have two conversations going on. You're receiving notifications because you subscribe, but you also have to renew your lease. So the conversations happen in parallel. So the composition model here is much more involved than with the messaging patterns, because I said messaging was easy, right? You have three pieces, you stick a fourth one on the end. It was the beauty of it, but it's also limiting. So here it becomes more involved, which means it's more powerful, but also you need to think a little bit more. You can get yourself into more trouble. So in the end, it's more valuable to have this pattern languages. Yeah, and that's what's going on. So coming to the end, because next agenda item is, I think, to have drinks, so we should finish roughly on time, is that what we found out, right? We talked about messaging patterns, we talked about pattern languages, and we talked about the conversation patterns. So we clearly saw that enterprise integration is more than just messaging. There's more patterns to be had. And the next ones are the conversation patterns. Eventing patterns are also distinct. All right? So there could be really more pattern families and pattern language. The other thing we realized, the pattern isn't just a recurring solution to a problem. It's much richer. Right? It discusses the whys about it. It has a name, it has an icon, it has visual, and it has a context. It lives in a language. Right? A pattern language is more than just, oh, here's like 10 patterns. Much of the power comes, how the language is structured and to help you navigate the language. That is really what in the end makes this useful. So in my case with the conversation patterns, it's work in progress. So you can find it, the website is EAI patterns or Enterprise Integration Patterns, right? Like the title of the book. And you can find the conversation patterns. You can follow along, and every so often I also blog about where I am, and I blog some updates. And Dave said I'm also these days working on things that have less to do with messaging, but more with organizational transformation. So if you're interested in that, there's actually a book out on LeanPub, and it has the fancy title of 37 things one architect knows about IT transformation. But luckily, I didn't make the URL that, but it's only called leanpub.com/37 things. So hopefully this was an interesting look a little bit into the head of a pattern author, a pattern designer. As I said, the patterns you can read up, but what I wanted to convey is a little bit how does the thought process work, and what is behind discovering and documenting those kind of patterns. So with that, thank you for coming. I hope you enjoyed the talk, and next agenda item is we have a reception and we have drinks. I will be there as well. So if you have questions, you're welcome to come by and have a chat. Thank you very much.